All right, we're going to talk about radicals again. Some of this is review, some is not. The nth root of a is a radical. So I'm reading right here. The nth root of a is a radical. A is the radicand, n is the index. Remember that an nth root undoes an nth power. So something like the square root of 7 squared is 7. The cube root of 5 cubed is 5, and so on. We can use these two properties, the nth root of a product is the product of the nth root, to simplify radicals. For instance, I could take the square root of 36, recognize that 36 is 9 times 4, and I could write that as the square root of 9 times the square root of 4. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 6. And yes, the square root of 36 is 6, because 6 times 6 is 36. So we can use this property to help us simplify radicals. We can also use the fact that the quotient of a fraction, in other words, if I have a fraction under a radical, I can make it a radical applied to the numerator and a radical applied to the denominator. Square root of 25 is 5. Square root of 16 is 4. So the square root of the fraction 25 over 16 is 5 over 4, which means 5 over 4 to the second power is 5 times 5 is 25. 5 squared is 25. 4 squared is 16. It checks out. Okay, square roots undo squares. A radical is said to be in simplest form, or a radical is simplified. It's called simplest radical form when there are no nth powers underneath an nth root, there are no fractions under the radical, and there is no radical in the denominator. And we're going to dive in and do some examples of simplifying. So we're going to start with the square root of 48. Several different ways you can do this. One way is to take the 48, write it as a product of primes. 48 is divisible by 2. It's 2 times 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So we can keep breaking down that 48. Now, there's a 2 squared. There's another 2 squared right here. And then there's a 3. So what we do in practice, the square root of 2 squared is 2. Square root of the other 2 squared is 2. And then the 3 stays underneath. So we have 4 times the square root of 3. Now, what they talk about in the Big Ideas textbook is we can take that 48, find the largest perfect square factor. 16 is 4 times 4. It's a perfect square. 48 divided by 16 is 3, or divide by 3 first, either way. And what we have is the square root of 48 is 16 times 3. So another way of attacking this problem could be to rewrite the 48 as 16 times 3. So different options for how we can solve this. And we will look at both of these options as we do some more examples. So cube root of 81. Now, we've talked about this one before. 81 is divisible by 3. 81 divided by 3 is 27. 27 is 3 times 9. 9 is 3 times 3. So notice what we have. We have a 3 to the third power and another 3. Cube root undoes the cube. So the cube root of 3 to the third is 3. And we have a 3 left underneath. So we got lots of 3's running around here. All right. Square root of 175 x squared y to the 5th. So we'll talk about how to do variables now. 175, there's a 25 in there. So that 175, I can break it down into a 25. And what is 175 divided by 25? 7. There's an x squared, and in that y to the 5th, there's a y squared, another y squared, and a y. right? And square root of 25 is 5. Square root of x squared is x. Square root of y squared is y. Square root of y squared is y. And then who stays underneath? The 7 and the y. Instead of writing y, we'll write y squared. And there is our solution. All right, fifth root of 96, m to the 7th, n to the 30th. Now we are looking for fifth powers. I need a factor that's raised to the fifth power, because fifth roots undo fifth powers. So we're going to break this down. 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. 1, 2, 3, 4, 5 2s. So 96 is 2 to the 5th, right? I don't really need to circle that. So it's going to be the fifth root of, there's a 2 to the 5th power times a 3. In that m to the 7th, there are 5 factors of m, and then an extra 2 factors of m. 30 is divisible by 5, so we're going to do this. We're going to make that n to the 6th to the 5th power, and then 2 comes out, m comes out, n to the 6th comes out. So remember that fifth root undoes a 5th power. And then we have a 3 left underneath and an m squared. And we're done. Okay, square root of 1 over 49. Let's use our properties. That's the square root of 1 over the square root of 49. Square root of 1 is 1, square root of 49 is 7, and we are done. Just that simple. Okay, next one. Square root of 12x over the square root of 25 w to the 6th. Another thing I want you to think about, well, let's just finish this up. 12 is 4 times 3. So I have 4 times 3 times x. I'm going to take that w to the 6th power in the denominator and write it as a w to the 3rd squared. Square root of 4 is 2. The 3 and the x both have to stay under the radical. Square root of 25 is 5. And then I have a w to the 3rd because the square root is going to undo the square. And we are simplified. Okay, part G. Again, once before we talked about the fact that when you have a cube root of a negative, you can pull the negative out. We're going to take that 54, and we're going to notice that it is 2 times 27. I'm going to take that x to the 4th and write it as x to the 3rd times x. Let's see, 27 is 3 to the 3rd power. So the cube root of 27 is 3. The cube root of x to the 3rd is x. And then underneath the radical, we have a 2 and an x. And we are done. Okay, part H. Cube root of the numerator divided by the cube root of the denominator. Cube root undoes the cube, so we have x, and the cube root of 8 is 2, because 2 times 2 times 2 is 8. And we're done. All right, adding and subtracting radicals. We're going to simplify something that's fairly basic, 3x plus 2y plus 5x, and then I'm going to use that to show you how we can add and subtract radicals. So 3x plus 2y plus 5x. You look for your like terms. Then you combine them by adding their coefficients. 3 plus 5 is 8. So we have 8x plus 2y. Now, the way this is going to help us is when we're doing radicals, think about this. How would you simplify this? You're going to do the same kind of thing. You're going to do 3 square roots of 2 plus 5 square roots of 2. Notice this one's a square root of 7, and it's different. So we find the ones that are alike, and we combine them. 3 plus 5 is 8. So we have 8 square roots of 2 plus 2 square roots of 7. Same idea as adding 3x plus 2y plus 5x. When you are adding and subtracting radicals, you will combine the like radicals. They have to have the same radicand to put them together. But you also need to be sure to simplify before you combine. So we're going to look at example 2, part A here. Find the ones that are alike. 5 square roots of 7 minus 8 square roots of 7 plus square root of 11. 5 take away 8 is a negative 3. Just like doing 5x minus 8x and getting negative 3x. Square root of 11 is not like the other radical pieces, so it doesn't go together with them. Okay. Part B. 10 square roots of 5 plus 2 square roots of 20. Now, what I want you to notice when you look at this one is 20 is 4 times 5. So what we're going to do, we're going to make that 10 square roots of 5 plus 2 square roots of 4 times 5. The square root of 4 is 2, so there's a 2 coming out. Multiplying with the 2 that's already in front, 2 times 2 is 4. Now I have 10 square roots of 5 plus 4 square roots of 5, which is 14 square root of 5. Notice we weren't able to put them together until we simplified that square root of 20. So simplifying that radical and then combining the like terms, the like radicals. Okay, this one's going to be really complicated, so let's go to work. Actually, you know what? We've already done this. The cube root of 81, remember, 81 is 3 times 27, so that cube root of 81, I'm going to remember that it's 3 times the cube root of 3, because the 81 is 3 times 27. So as we simplify that, we're going to have a 3 coming out and multiplying with the 4, because this is 27 times 3. So 3 comes out, multiplies with the 4, and we have a 3 left underneath. I'm going to shuffle things around just a little bit because I cannot put together a cube root with a square root, so I'm going to move that square root back here so that it's next to the other square root. Those radicals are not the same if the indexes are different. So now I have 1 minus 12 is negative 11, plus 2 is negative 9. I have negative 9 cube roots of 3. And then I have negative 1 plus 5 is 4 square roots of 3. And we're done. Then we could switch the order of these and make it 4 square root of 3 minus 9 times the cube root of 3. And that's our first page of the radical notes.